Hello, everyone, and welcome to this session about micro-frontends. You know, in the past 10 years, we have seen an evolution in distributed systems. If you remember well, we started to address the first problem on the backend, and we started to have microservices and later on cell-based architecture. But 10 years ago, we started to apply the same principles in multiple layers. We started to apply on the front end with micro-frontends and on the data side with data mesh. Because we have seen that we reason better with smaller problems, and we can solve them very well. And if we start to distribute this system properly across our teams, we can achieve more in less time. And today we are going to talk about one of those evolutions. We are going to talk about micro-frontends. And in order to do that, I thought that it would be great to have also a case study and see the real value of this architecture. My name is Luca Mezzalira. I'm a serverless specialist solution architect in AWS. I'm based in London. And with me today, I have Ivan.
Hello, I'm Ivan Rigoni. I'm a digital solutions architect at Formula One Digital Technology.
OK, so the first question we need to address is this one. How can we scale a front-end application? And this is a problem that I had almost 10 years ago when I was working in a live sports streaming platform with, let's say, a very great potential. And we moved very quickly from tens of people to thousands of people, like in less than 18 months. And as you can imagine, you know, dealing with these kind of problems, it means that you need to think about scale. But we have a solution on the back end. We didn't have a solution on the front end. So when I think about that, I was thinking back in the days, oh, sorry, I was one slide back. Sorry, my bad. When I was thinking about that, I was thinking, OK, so usually when we think about front-end application, we start to think about components. And we look into, OK, so this is a component that wrap, I don't know, the header or the marketing message, whatever it is. And when we want to work in distributed system, we need to think about something different. We need to split them up and start to think about how can we have like maybe a team working on one portion and another team working on another one, right? So it seems easy, the problem, because we can reuse the components and then use it across all the different teams. So one team is responsible for a component and one team is responsible for another one, done. Unfortunately, not quite, because the problem that we have missed is that an architecture, especially a distributed system, is not just the technical part. We need to think about a lot of other dimensions. The engineering culture. We need to think about the organizational structure. We need to understand the governance, the ownership, and all the other characteristics that makes a distributed system successful. But before we move on, let's try to be on the same page. So usually, a component is very different from a micro-frontend. Because this is the classic mistakes that I've seen with many companies that are embracing for the first time micro-frontends. Since up to now, I helped hundreds of teams worldwide from Australia to Silicon Valley moving into micro-frontends. And the problem is that very often I've seen this anti-pattern, where they think about components and not micro-frontends. So in a component, for instance, let's take a classic example, a button. And a button, you know, the first thing that you do probably is the possibility to expose a property and set a label. And if your buttons start to have success inside your system, maybe you can also have an icon associated to that. So if someone's set up the icon, then it will have the icon and the label. Then if your button became very successful inside the organization, you can have change the border color, you can have different rollover animations, you can have the auto size dimension, and so on. So you start to abstract a lot of capabilities of the button and make it reusable across multiple parts of the system. And that's the reason why we created the component. We want to reduce the duplication, and we want to optimize for reusability. But there is a problem in distributed system. Because reusability is a form of coupling. Then don't take my word. This is a quote from Neil Ford. that have done quite a few things in architecture. So what's the difference between components and micro-frontends? And that's why people struggle very often. So a micro-frontend is very well aware of the context, and in fact, is encapsulating the state of that has to operate one. Because if you think about the button is exposing all these properties, but someone has to instruct the button how to behave. And usually, it links the domain up to the container of the button. And it's the same for any other component. But the micro-frontend encapsulates its state. And therefore, it has knowledge on how it should behave. It will have maybe a couple of properties, maybe the token, the session token, or the ID of a product, but nothing else, because the micro-frontend is aware of its context. It has to be, because otherwise, you are going to have a leak of domain, and therefore, it means also you don't reduce the external dependency for a team, but you start to have constant coordination, like you would have in any other case. That is exactly what you don't want to have in distributed system. You usually define input and output. So think about in domain-driven design when we talk about bounded context. We identify the API that we want to communicate with a system or a service, and then the output of the service. And it's very important. And usually, it's less extensible. You're not building micro-frontends for the sake of maximum reusability. This is for components. Micro-frontends, as we said, are context-aware, and they should be able to create teams that are strongly independent. And by the way, we are reducing external dependencies, not eliminating one. That is very important. So I created, let's say, a rule of thumb that is used quite widely in the trenches for understanding if you create a proper micro-frontends boundary. So usually, you don't have many API exposed. If we think about the button, you start to have a lot of properties that you expose because you want to have reusability. Micro-frontends, you don't have many. Sometimes, by convention, you say, check in the local storage to find the, or in the cookie to find the session token, and check on the query string to find an ID. The second thing is our context aware. We discussed about that. The third one is, if you start to have a micro-frontend that is reused everywhere, it might be a red flag, okay? That is another important thing. Might be because if I think about the footer, maybe due to code volatility that is very low, then you might think that it can be reusable in multiple places. And last but not least, micro-frontends are more coarse-grained. Usually, a rule of thumb is if you have in a view 5, 6 micro-frontends, it's more than enough. If you end up having tens of micro-frontends, then probably you are building distributed components. That is exactly what you don't want to do. And therefore, I coined this definition several years ago, almost 10 years ago, because I had to express something that was very difficult to grasp for developers. Imagine 9 years ago when the term micro-frontends didn't exist. I was pitching this to hundreds of engineers that were staring at me saying, what are we trying to do here? And in reality, micro-frontends are a technical representation of a business subdomain, and they are aiming for independent implementation with same or different technology. They minimize the code shared, and they're owned by a single team. So now we are going to drill down into every single characteristics of this definition in order to understand how you can create the ideal micro-frontends platform. But first of all, let's start with a very important thing. Why do we need micro-frontends? Why we should embrace them? There are a few benefits that we need to think about. But first of all, I have seen customers that are looking to use micro-frontends for incremental upgrades. They are tired to wait months before a micro-frontend is deployed because maybe they have a cadence of every month they make a release or every, 2 months or whatever it is. I've seen companies, and I was part of one of them, that moved from 2 releases per month to 24 per day per micro-frontend. That's what we want to have. We want to have fast flow. We want to have guardrails that enables us to do that. You want to have decentralization. for instance, in microservices, right? So when you think about microservices, what you want to achieve is not only the technical part, so fault isolation and I don't know, scalability of a part of the system, etc. So you want to decentralize because you know that if you want to grow the organization, you need to have the possibility to plug and unplug teams inside the system and start to add functionalities. And it's the same here with micro-frontends. We want to reduce the cognitive load. It's another important aspect here because very often, when I have a new joiner and has to understand a large code base, it will take months before it starts to push in production. I have seen customers that were able to start and deploy in production in weeks. And this is amazing. And last but not least, bear in mind that distributed systems are not there for only scaling your technology system, but also your social technical system, therefore your organization. OK, so how many of you have heard about the Conway's law? OK, a few of you. So the idea of Conway's law is that you usually produce a design that is mirroring your organization structure. That is not something that is new. As you have seen, I have added a date over there, 1967. At the beginning, they didn't believe in Melvin Conway. But after 10 or 15 years, they started to see that and witness that. And therefore, in distributed system, it's important that you look into these two dimensions, architecture and organization structure. I added the third one that is engineering culture, but is another thing that we will touch later. So for instance, when you think about a centralized mindset, you start to think about that. And I work back in the days in this way. I'm a developer. I'm in the value stream teams or in the engineering teams. I start to work on my part of the system. There is no real reasoning behind how there is an input and output between teams. There is just a tech leadership that is defining certain things. And usually developers were throwing their code on the other side of the fence, and someone else will operate. But when we work on a distributed system, we need to think about decentralized mindset. Team topology come to the rescue here. Team topology is a concept that came out in 2019 and starts from the idea that we want to have stream-aligned teams that are dedicated on generating value, but obviously they cannot do alone. You need to have also some complicated subsystem teams where they are taking care about a specific area of the system that are supporting the other value stream teams in order to achieve specific requirements. So like in this case, the data science team is just providing some landing zone or whatever on API for providing this data, maybe clickstream from a UI. Then you have a platform team that is providing all the infrastructure and the foundational part of your system. But last but not least, we have a bunch of other enabling teams like security or developer experience. And specifically, developer experience is one, for me, of the key success for distributed system. That is front-end and back-end. But we need to understand also what's the relationship between architecture and organization. So we are going to drill down into these two dimensions. First, the platform team, and then the stream-aligned teams. And trying to mirror the capabilities on the architecture side and what it means splitting in this way the ownership of a platform. So let's start with the platform team. So a platform team is this one, just to be on the same page. It's the part that is not gray out. So platform team at the bottom and the enablement team. Those two will create the foundational part for a system. So usually when you start a micro-frontends, what I suggest is starting with a virtual team or a proper team that is, let's say, always together and created for defining what I call the micro-frontends decision framework. This one was coined in 2019 and is the 4 key decisions that you need to take in every single micro-frontends platform. Server-side rendered, client-side render, is always the same. Those 4 decisions are the foundational part of your system. You need to identify what a micro-frontend is. You need to compose it and how to compose it. Understand how to route between pages and communicate, how micro-frontends are communicating together. This is, I tried and applied in dozens, if not hundreds of architectures. And those questions, when they are answered, you will be able to have like a great starting point for your system. So let's try to drill down. Usually when I talk about identify micro-frontends, there are two types of micro-frontends. There is a vertical split and then a horizontal split. A vertical split is the one that is on your left. Sorry, on your right. A vertical split is when we have on your right. So you have a page or a group of pages that are representing a micro-frontend. And an horizontal split instead is when you have multiple micro-frontends in the same page. Those are not mutual exclusive. You can use both in the same system. Because if you start to understand what you need to express in a system, you can use both. Classic example, if you think a My Account area in your website, there probably you have payment. And probably you have another domain that is the user account, and maybe history of something, like gift code history, whatever. Those can be three different domains that you want to show in the same page for the user, but in your organization are mapped into three different teams. So you can have an horizontal split. While if you have, for instance, a catalog, and inside there you have all the things related to the catalog, it might be sufficient having one team taking care about that. So due to code volatility, we want to have, let's say, the identification of a catalog that is a unique chunk that then will be handled by the same team. After that, we move into the micro-frontends composition. So there, we can have a composition on the client side, as you can see on the left. It's arrived? OK, perfect. And there we have what is called an application shell. So it's an empty element that is loaded at the beginning of your application that knows how to compose micro-frontends. Is it through, I don't know, iframe? Is it through an import map? Is it through module federation? It doesn't matter what you decide, but this is very well, the application shell is aware how to do that. So on the server or the CDN, you have your artifacts. That's basically what your team are going to build, and that's it. On the server side, instead, we have, OK, so it's flipping around. On the server side, we have instead everything happening on server. So the application shell is basically composing different server-side render pages or part of the pages on this application shell and serve the final result to the user. We can do that? OK, perfect. Now there is the routing part. And the routing part works in this way. So routing means I move from one page to another one, and therefore I need to load one or another set of micro-frontends. And that case usually is the application shell on the client side has the logic for loading the right page base, or better, the right micro-frontend, and compose them. Similarly, in the server-side rendering, we have the routing that is happening on the server because the composition is happening on the server. And finally, when you have an horizontal split, very often you need to communicate between micro-frontends. For instance, imagine that someone selects an element inside a product inside an e-commerce, and you need to bump up the number inside the cart. Usually, you have an horizontal split in that case where you need to communicate. And very often, an anti-pattern is using a state management that is shared across micro-frontends. But it's like sharing a database between microservices. And if you change the database schema, you need to change everything else. So you need to use a pub/sub pattern for doing that. Therefore, an event emitter, custom events, or reactive streams are perfect companion for that. And either you're working with horizontal split or with vertical split, you can share stuff like, for instance, through the cookie or local storage of a session token, or just ephemeral data like an ID in case of the query string parameters. Now, there is another thing that we need to take into account when I talk about application shell. So this empty element that is loaded at the beginning of your application will remain there for the entire user session. The first one is has to be as vanilla as possible. Very often I've seen companies using a framework to be Angular, React, whatever. But the problem with that is that we'll create more complications if you start to have multiple frameworks to handle. Or if you want to migrate a different framework from, I don't know, React to Vue.js or vice versa. The second thing is that it has to be context unaware. Great rule of thumb, if your application shell is capable to load your application, but any other application, you are in a good path. Third one, expose initial configuration. So usually, very often in client-side rendering specifically, you have the first thing that you do is calling an API and a startup API, an initialization API, call it in the way that you want, that contains a configuration that is initial and shared across all the different micro-frontends. And last but not least, he has to be responsible for routing and composing, like we have seen. Now, the other part that is extremely important is thinking about the developer experience. Why that? Because we need to express certain architecture characteristics and try to shift them left as much as possible. We want to have a fast feedback loop for developers. Therefore, you can do very interesting things like performance testing or enhancement of performance. Classic thing that I have done in my previous job was every time that a developer was opening a pull request in their version of control system we were using, we were triggering a webhook that was taken by a Lambda function that was running with Webpack. We were building on the fly the micro-frontend. And if the micro-frontend size at the end has a threshold that was over 30% of the, let's say, decision that we made for that specific micro-frontend, then we block to merge into main. Because what we wanted to do is that because you're using micro-frontends, it doesn't mean that the performance don't matter. They matter. And you have even better performance when you use micro-frontends because you load only the code needed and not the entire application. The other thing is you need to think about how to update shared libraries. Classic things that I've seen over and over again is when, for instance, you have a design system and there is a new version of the design system that is across the micro-frontend. You don't want to approach every single team and say, oh, by the way, you need to update to the latest version. You want to automate that part. And therefore, you can use a solution like Dependabot and configure it in order to say, OK, every night, check if in the package JSON, if the version of the design system is the latest one or not. And if it is not, I open a PR. Or I send a digest via email to the team. The other thing you need to think about that you need to maintain the required security posture. For instance, you want to make sure that no one is adding API ID inside your front end. So you are going to scan all the backend just to make, all the version control in order to make sure that in the code, nothing is compromising your security posture. And obviously, these are just examples. You can have way more stuff that you can apply there. But it's important that you think about this because that will speed up the development of your application, and you will enable the developers to focus on what really matters without thinking about, oh, yeah, I forgot about that specific architecture characteristics. The other thing that you need to think about is deployment. Developer experience and deployment are going hand in hand very often. So I have a few characteristics that I have in my mind when I design a deployment for micro-frontend. First of all, I need to deploy incrementally. I want to do, let's say, as often as possible, and therefore, I want to have frequent deployment. And last but not least, probably the most important one, I want to have micro-frontends that are independent. The moment that I see teams that are constantly coordinating the deployment, it means that I need to go back to the whiteboard because something happened in the bounded context of this micro-frontend that creates coupling. And therefore, I need to avoid to have coupling. So when I started to think about that, I started to design a potential solution. And if I think what is the best pattern for solving this problem, it's called the discovery pattern. We have seen microservices and service mesh quite a lot. But why not having a micro-frontend? And when I start to see this, where an application shell is calling the discovery service and retrieve what micro-frontends should load, this part that I highlighted can be easily abstracted. I can have one that rules them all. And the beauty of this is that because I'm lazy loading micro-frontends, I can also decide how to deploy. We have learned in the hard way that we don't want to have a big bang deployment of microservices. We want to have a canary release. We want to have a blue-green deployment. So why not solving this problem once for all? So with a bunch of other architects in AWS, we created what we call the front-end discovery service. And this one is just an open source service that you can find in AWS Labs. And basically, it's composed by two areas. One is the back office that the backend can be plugged in any CI/CD, where there are a bunch of APIs that you can use, and just create a new micro-frontend and decide how you want to deploy. And this part instead is the front-end side that is used for your application shell on the server or on the client, doesn't matter, to retrieve what is the right micro-frontend to use. And the application takes care on doing the rollout in the way that you want it. Could be a big bang, could be canary release, could be blue-green deployment. So if you're interested in that, the project is already available in AWS Labs, and this is like the link for the project. It's already used by a dozen of our customers, and it solved the problem once for all on deployment of micro-frontends. Now let's move into value stream teams. Okay, so those are the one in green are the value stream teams. So we have to go back for a second about our definition. This is a problem we have seen over and over again. Same or different technology, we said. The problem is when you have multiple technologies and optimize for that, you end up with micro-frontends anarchy, as defined by ThoughtWorks back in 2017, 2018. And this is what you don't want to optimize for. There is a period of transition from the current architecture to a micro-frontends one that you might have 2 or 3 frameworks. But you want to optimize for a single framework because it's not a playground for developer that you're building. You are building a solution for your customers. Therefore, they don't have to be penalized because you decide to have multiple frameworks. The other thing that we need to think about is minimize the code share. This one, when I proposed this idea in the front-end community, it was very difficult to get the buy-in from there. But the reality is, when you share code, you might risk to have nasty abstractions. And therefore, what you really think about that is that you want to reduce the external dependencies. That is your main goal when you do distributed system. You want to optimize your team for fast flow. And you want to embrace a lean mindset. If you duplicate now for a couple of teams a portion of your system, and you decide later to abstract that, you will have by far more success and more input to understand how to abstract and where to abstract, more than starting from the abstraction and then trying to split it up later on. Classic example. Think about rate of change inside as a heuristic. So if I have logging, analytics, design system, and data layer, those are classic things that I've seen shared inside the system. But logging is fine. The rate of change is not very high. Analytics, when I have a library for analytics, probably change every 6 months, 1 year, top. The design system is changing more frequently, but usually maybe at the beginning there is more effort because you need to update the new version. But then in the long run, it's not going to change every day. But what about the data layer? The data layer can't change very often. And that's usually let's say, a good library that I prefer to have inside the micro-frontend, that every micro-frontend is handling its own data layer, more than sharing it and then having all the if, else, and complexity and logic that I need to maintain. The problem is not writing code, it's maintaining code. So let's go for the last part of this, the definition, ownership. So when I think about the micro-frontend, if I want to design my system properly, I need to think that a team should be able to code it. Fine, we have seen that. Testing it independently. Deploying and monitoring independently doesn't mean that you don't have to provide tools, but it means that they can decide when they need to deploy. And also adhere to guardrails. Those 4 things need to be present in every single team. Now, before we go ahead, I want to show you, apart from, let's say, these different rules that I describe, I want to prove you that micro-frontends can have a massive impact in your business. And because of that, I have Ivan here with me that will tell us about the story.
Thank you, Luca. So I said earlier that I'm a digital solutions architect at Formula One digital technology. So let me clarify what digital technology department and domain is at Formula One. It is composed of 3 subdomains. First one is the core domain, which I belong to, including the Formula1.com website and Formula One apps. There is F1 TV, website, apps, and smart TV app, and Fantasy, which is the gamified experience which allows you to pretend to be a Formula One team manager and earn points during the season. At Formula One digital technology core domain, we are on a mission. We want to increase the web and app traffic, have people consume more content, more advertising, of course. The end game is to obtain more sign-ups to our free content offering, which is F1 Unlocked, and, sorry, just too fast, and the F1 TV subscription-based streaming. But we have to cope with, sorry, what did I do? We have to cope with human nature. Bear with me. According to a large scale conducted by Akamai in 2015, 49% of users expect a website or app to respond within 2 seconds to any interaction. An additional 30% expect it to happen within 1 second. So that was 2015. We're talking already about 79% of users. What does that mean? It means that you're looking at the slide, and after 1 second, your attention is completely elsewhere, which is the reason why you should talk faster. No, maybe not. So let me begin with what we achieved by introducing micro-frontends. And first and foremost, the business aspect. I mentioned that we wanted to increase web and app traffic. There's a number there on the screen, plus 34%, and that counts only the additional subscriptions and sign-ups to F1 Unlock and F1 TV from January to September this year. So number might be higher now. And it's not, of course, it's not only because of the introduction of micro-frontends. Certainly there is a contribution from better content, but for sure, that number says that there's a massive contribution from micro-frontends. And that's because the website is faster. Financially, we had a benefit, minus 26% platform cost, just by shifting the workload from Amazon EC2 to AWS Fargate. What does that mean? It means that we are better using AWS resources. It means that we are more sustainable, better for the planet, and better for our pockets as well. User side. This is the lighthouse performance score increase on web and mobile web, plus 30% on web, plus 56% on mobile web. Massive. I'll give you more details, a breakdown actually of this performance increase later. And finally, let's not forget about software engineers, many people in this room. The benefits that Luca already highlighted. We have less cognitive load. That means more focus on a single micro-frontend. You can develop, test, and deploy independently each single micro-frontend without having to regression test the entire platform. And having a faster user experience means also that tests run faster, so you can deliver more. And the second benefit is the integration of the design system with automation, as Luca has highlighted. From the point of the submission of a new approved design to creation of the corresponding web components, well documented in Storybook, an engineer picks up the new web component, applies the logic, whatever needs to be done from a business perspective, and then pushes the new code down the deployment pipeline, where we test also for accessibility regression through Chromatic, if I'm not mistaken. So you see, we've seen 4 big aspects where there were benefits. Of course, there are downsides, just one. The website still looks the same. So if you were ideally to go back to April 2024 and visit Formula1.com, few pages, and then come back to now and visit the same pages, yes, you probably see different content, more engaging content, because the season has moved on, the championship has become more exciting, I think. But visually, it looks the same. It is massively faster. So let's have a look at what has changed under the hood, because that's where the changes happened. So up to 2018, Formula1.com was running on a traditional 3-tier monolithic architecture. So database, application server, generation of HTML and JavaScript server side. We all know the limitation of such a system. You can only scale out to a number of instances, limited, before you begin to hit limits and adversities. And releases actually become a painful affair because every little change you have to make, you have to regression test the entire website to ensure that nothing has been impacted adversely. So you tend, of course, to aggregate more changes in a single release, so you have to regression test only once. Releases become riskier. You know the lot. So we wanted, of course, a more composable architecture, and we began by extracting the editorial capability outside the monolith to contentful. So clean separation. The Adobe AM monolith still serves the pages, templates, data, whatever is needed, but the content is pulled from contentful, and we created 4 content atoms that were our embryonal micro-frontends: header, navigation bar, content area, and footer. That's pretty much the structure of the entire Formula One website. Let's move on. And fast forward to 2022, when we began to do a more serious job. And that's been identifying, from a domain-driven perspective, the domain boundaries of a context where there were little or no dependencies with the rest of the monolith. And that is the journey of purchasing a subscription of Formula One TV. So self-contained domain that was easy to extract onto a new architecture, which is depicted by the ECS cluster props you see there. Props is a contraction for proposition pages, where we propose you to buy our subscription pretty much. And fronted by an application load balancer, and incoming traffic is routed to the props pages if the user intends to purchase a subscription. Anything else goes still to the monolith. As soon as CloudFront functions became available, we migrated the behavior to the CloudFront functions instead. Interestingly, we kept the page structure for the prop pages. The only difference is that the outer frame, we call it the application shell, is now implemented by a Next.js 12 application. So the experiment has been so successful that we kicked off the entire rebuild of the Formula1.com website in micro-frontends. So, but let's begin from the business requirements. As any project, you need to justify why you're doing this exercise. There has to be a value to extract somewhere. We wanted a faster, scalable, highly concurrent website. Of course, we've seen why faster. Faster means more engagement, and the end game, more subscriptions. Scalable and highly concurrent because of the nature of the Formula One business and any sport streaming platform. You have users piling up at the beginning of a sport event and then pretty low traffic for the rest of the week. Optimized for fast flow. Yeah, we want to deliver more, deliver faster. Modern test stack, as any software engineer can attest, more modern tools mean going faster. Improve accessibility. We want to widen our user base and cater for those users with special needs for them to enjoy Formula One to the fullest. And finally, be able to experiment faster. Think A/B testing and multivariate testing. So how can micro-frontends address these needs, these requirements? Well, with independent testing and deployment, faster delivery of changes, and full integration with the design system, and interestingly, more granular caching policies. Why is that important to Formula1.com? Because, of course, we have areas of the site that are less prone to be updated. Think of 1950s season standings that will hardly change over time, as opposed to breaking news, the breaking news area, which is updated pretty frequently. So they have different caching policies. And finally, better support for higher accessibility. So that said, now we decided we want to go fully into micro-frontends. So what do you have to do next? You can employ people like me or Luca who are not at the first experience in delivering micro-frontends transformation, but you are very lucky nowadays that there is plenty of literature out there, and let me also shamelessly advertise Luca's book, Building Micro-Frontends, at its second edition, that contains a chapter, already mentioned, on the micro-frontends decision framework. For me as an architect, the most important job is that of facilitating those decisions that are hard to change in the future. Because those decisions are the ones that shape the solution design. What are those decisions? Identify the domain boundaries within your page structure. So what is this section? Who owns that section of that area? What organizationally, I mean, and how is the structure laid out? For Formula1.com website, single page applications with vertical split were the obvious choice, because we have a page which is the article listing, another page which is the video listing, another page which is with all the stats and standings and drivers and teams and whatsoever. So they are owned by different domains, but the page structure is pretty standard. So you have header, footer, navigation bar, content area, which can include multiple micro-frontends. Next decision, compose. Do you compose on the client, on the server? For us, the choice was easy. Even for the pages where the content changes very frequently, like latest news that I mentioned earlier, we serve the same response millions of times, so there's no point in having it generated on the client. We generate it on the server and then push it to CloudFront. Server-side rendering, then obvious choice. Next, routing or routing, depending on the flavor of English you speak. That's how it is. So you, of course, can route a front end or a back end, but once you choose server-side rendering, the choice is restricted to, of course, server-side. And then still you have multiple choices. You can do reverse proxy with Nginx, but of course you have Lambda, Edge, and CloudFront functions. Why not? They work pretty well. And finally, communication across micro-frontends. Do you have the need for passing data across various micro-frontends, messages? Do you need a publish-subscribe mechanism? Well, we, inspecting our website, as it was before, we saw that in 90% of cases, there's no communication whatsoever across the micro-frontends. There's only the need of communicating from the application shell to the micro-frontends that are loaded. So unidirectional. Now, you have the choice to deliver these changes in a big bang approach. So create the new system and then switch over when it's ready. We know it's risky. Or you can do it in a test and learn iterative approach, which is the choice we made, and which is also the one represented on screen. On the bottom left, you see the legacy system that had a number of capabilities in it, as I mentioned, content editorializing, templating, ingestion of the FIA official data, teams, drivers, circuits, whatever. And from that system, we were chipping away functionality, one by one, starving traffic from the existing functionality, and bringing the traffic to the new functionality delivered in the new micro-frontend-based system, utilizing what is called the Strangler fig pattern. Along the way, we also discovered that there were functionalities that were prone, I wouldn't say prone, but they could have been used also by other domains, F1 TV mentioned earlier, and fantasy. For example, the use of data, teams, drivers, circuits, as I said earlier. So we extracted that part to a self-contained system, which is on the top right, called the data structure layer. And the same was for imagery, media assets that have been delegated to Cloudinary so that the other domains can use it as well. The rest of functionality has all been migrated to micro-frontends. So now we decided micro-frontends. We chose the approach of delivery. You might be interested in seeing a real release plan. And then, courtesy of our partners at Digitas Publicis Group, here is the actual delivery plan that we use to deliver the transformation to micro-frontend or the Formula1.com website. First and foremost, we deliver the application shell. That's important, including header, footer, and the all articles listing micro-frontend. And then on, release by release, we've been adding functionality. You see, just shifting to the right, the magenta boxes depict the new functionality which is added at each release until we reach 100% of shifting the traffic. And the final architecture is the one on screen now. So all the EC2 boxes on the right-hand side have been replaced by a bunch of ECS clusters, each one representing a page of a Formula1.com website that aggregates a number of micro-frontends and is fronted by an application load balancer. Routing is done by CloudFront functions, and you see the two new systems as well. So now let's go back to the performance that I anticipated earlier. And let's drill down into the KPI. What common KPIs used are the web vitals that you probably know pretty well. Let's have a look, for example, for the page latest F1 news, which is the first one we delivered, on web at the first contentful paint. So 2.0 seconds in the legacy system becomes 0.8 seconds in the new system. Yeah, pretty good achievement, right? Speed index goes from 4.3 to 3, but if we remove all the unnecessary code, like tracking pixels, like advertising, like all that stuff, it goes down to 0.6, which is pretty impressive. And that's web. Let's have a look at mobile web instead, which is the next slide. Same page on mobile web. So let me point your attention on the largest contentful paint. 8.7 seconds in the legacy system. Outrageous, to say the least. It goes down to 3.2 in the new micro-frontends based one. Speed index, 7.3 to 5.2. And again, if we strip out all the unnecessary code, 2.2. And finally, to summarize it all, the Lighthouse performance score, which aims at representing with a single number all the numbers you've seen before, goes from 53 to 83. It is a massive performance increase. I hope I kept you entertained and interested, and if you see something real on the ground on micro-frontends. Now, back to Luca.
Thank you, Ivan. OK, so yeah, you should go. I think it was very interesting hearing, let's say, a real story from the trenches about a website that everyone knows, but more importantly, also seeing the migration of this. But before we leave, I have a few other things that I would like to share. So micro-frontends, that is very controversial sometimes, because at the beginning, people were complaining in the community that micro-frontends will not improve the performance, we compromise the performance. But in reality, we have seen that is not true. It is not only for F1. I can tell you many other customers that the fact that they are going to load just the code that is needed for representing a page will have a massive performance boost in every device. Before, let's say, joining AWS, I was working in a live sports streaming platform, and there we had a lot of living room devices and set-top boxes to address. Therefore, low-end devices that are far away from the quad-core or 8-core or 20-core Macintosh that we are using nowadays. And there we were able to streamline the startup of the application, moving from a single-page application to a micro-frontends one by probably if I was 40 seconds on startup on a device to 10. As you can imagine, it's incredible what you can achieve when you start simply applying micro-frontends. Because instead of before, where you need to think about holistically the package size of a specific front-end, now you need to take just a portion. And it's very likely that your users are not going to load always the entire website. They're not going page by page to check everything. They will go there in order to, let's say, load just what they needed in order to consume. The second point is that micro-frontends are a complement strategy of microservices. When we think about distributed systems, what we are aiming really for is having teams that are independent, so reduce the external dependency, because that will accelerate the fast flow, as we have seen today. And therefore, if you have a distributed system on the back end, it's likely that you want to have the same thing on the front end. It's not, let's say, 100% sure, because it depends from your context, obviously, but it's very likely that you should look into micro-frontends. The third thing is that micro-frontends, because are reducing the cognitive load to your teams. Now they became domain expert. You decentralize the logic of the decision-making and the logic that they need to apply inside an organization. Then you start to have a fast flow. Because if you look into how you can, let's say, reach a faster deployment time and start to have, let's say, a team that have skin on the game and start to deploy properly, having micro-frontends that are just some strong boundaries on how to use that will enable them to have the time not only to write the code, but also to take care of all the other things that we have seen before. And last but not least, you will make your teams independent. And therefore, we know that the ownership part is a key aspect for developers nowadays. There is more the developers are involved in not only writing code, but also in the decision-making. So the possibility to take a pattern to apply inside their boundaries that doesn't affect anything else, it will make, let's say, them obviously more successful in, let's say, creating their platform. I hope that you really enjoyed this session, and we still have 10 minutes, so we have time for a few questions. And thank you very much for attending us.